So good morning, everyone. Almost lunchtime. It's loud. So did I say anything wrong this morning, Tom? Was I reasonably good? So within this session, what I wanted to talk about, I'm not sure if you attended the earlier one, is really open architectures. So if you were at the keynote on yesterday, there was a session that they talked really about, Rajiv talked about these open architectures. And I'll go into a little bit more detail with architectures and where they're going and the benefits, and actually kind of the double-edged sword on how, these open architectures, can provide some confusion in the market as well. Within the networking environment, it's hard. We used to say mobile networks and telecom networks and enterprise networks. And if you think about all the gear and all the hardware and all the assets that are going into these different networks, it's really becoming a converged environment. So in the communication markets, you have, the 4G, 5G mobile network, you have cable, you have telecom, and you're actually seeing a lot of the main carriers starting to consolidate their divisions into one networking company. You've got AT&T and DirecTV, you've got Verizon and Fios, you've got all these different companies that are starting to merge and utilize the different technologies. And over time, those technologies will utilize a lot of the same equipment. They'll use some of the same software stacks, a lot of the same containers and virtual network functions moving forward. And then you have a lot of introductions into service revenue opportunities for the operators, such as IoT, Internet of Things, that entire infrastructure that can utilize not just the carrier's networks, but also provide services from the carriers to their consumers. You have these new things called multi-access edge computing, you have video media processing, all kind of really becoming consolidated and converged. And then you also have a lot of adjacency markets that, the defense. Think about our soldiers, they're still using walkie-talkie type technologies. They really like the LTE infrastructure and using that into a battlefield space for command and control. Mining and industrial opportunities, again, rugged carrier-grade type gear can be put into mining and industrial environments. Transportation, how trains and planes and automobiles are evolving, and the technologies that they need are also consolidating into the telecom world. And then, of course, private cloud and enterprises are also being utilized not just in the telecom world, but also private and enterprise worlds as well. So if I was a CTO or an IS/IT director, the things that I have to look at are my needs versus the value of those needs and the overall cost of those needs. I can go low end. I may need something as cheap and low end as possible, or I need to go as high end as I possibly can, but with that has value and cost around that. So do I look at appliances, small 2U, 4U type servers, or do I look at an entire rack? Do I look at Intel versus ARM versus NVIDIA versus AMD and so forth and so on? What are some of the silicon requirements that I can pay today that will get me the benefits in the future? How about replacement? So, where do I want to put this gear? Is it in a controlled environment, a nice air-conditioned, raised floor, beautiful type data center, or is this going to go into a 1920s central office that has concrete floors and, asbestos and earthquake zone within San Francisco? Where do I actually want to put this stuff? How do I want to build it out? What's the life cycle of the product? Is it a 1-year life cycle? Is it a 10-year life cycle? Do I want to be locked into a vendor? I may have great friends at HP or ADLINK and, oh man, this is awesome, but do I really want to spend the rest of my life with that partner? And also, do I want to buy something very proprietary that's purpose-built for my reason, or do I want more open architectures? So now becomes the brain freeze and the total confusion in the world. So over the past, 10 years, actually more than 10 years, but more and more lately, are just a lot of the committees and the open architectures that are being developed that enable a stack of software that could live on hardware assets that can meet the challenges and needs of our converged network providers. We have ONF, Open Network Foundation. We have CORD, MCORD. We have Open Compute. You know, I consider us being a big committee in an open architecture environment. You have the old Telcordia days that actually drove a lot of the specifications for the telecom environment for hardware. You have TIP, the Telecom Infrastructure Project, which is now kind of part of the OCP family that are driving use cases, and we have Tiger teams that are implementing great things that are using hopefully OCP gear. You have Open 19 Foundation, Open NFV, Open Mano, which is a management aspect for NFV. We have Redfish, DMTF. The list goes on, and this is only a subset. If you were at the keynote, he had a slide that had twice as many open architectures as we see today, you know, Open BMC, Edge Consortium. And you also, because we're also converging all of these networks, you're seeing other opportunities of things like fog. Fog is the IoT term for edge. They're starting to develop types of specifications, and they have their own committee groups. So with this entire aspect of all these networks converging, as an IT professional or as a CTO, how do I do this? Where do I look at it? I mean, it's great I can go to the open world, I can look at these committees, but what is the right fit? What do I actually want to look at? If you were in my earlier session, from a hardware standpoint, you know, we're going from rack mount servers all the way going into 2021, in which, you know, a lot of the needs are increasing, more density, more speed, throughput. The amount of virtual machines that I can offer within a footprint. You know, Intel was talking about photonics backplanes and self-healing systems, using analytics to recognize, hey, my fan speeds are going slower, how do I self-heal? You know, reduce power, which is another big concern. So from a hardware architecture, I think we're on the right path. I think we're now getting more into a post-proprietary world, into more of an open architecture world that provides viable options to all of these converged network providers, different attributes of silicon, different attributes of hardware acceleration, and really overall solutions that can have stacks that live up on top of it. So for me, I think a key checklist would be, first, I want to have a reusable, scalable architecture. I want to have the ability to maybe buy one sled that could fit a 2U, 4U, 6U, an entire frame. If it's a GPU, a GPU, or a ARM, maybe I'll just want to have my asset as that sled, but that sled can fit into different types of environments. So that goes into common modular building blocks. In a proprietary nature, I can do that, but I have to use that proprietary vendor's equipment. Maybe I want to use an ADLINK and mix with a RAID-Assist and mix with a Advantech and all the other suppliers out there in a plug-and-play type system. It needs to be scalable, so again, it goes back to, I only may need 10 gig today, but is it configurable up to 100 gig in the future? Things like copper, how I actually integrate it within my system. Do I use fiber? Is it a software change that make me go from 40 gig to 100 gig? Mix and match compute, in a lot of cases, everything is not just x86. So a lot of things have to have hardware acceleration to be able to manage a front-end data plane environment to look at things like DPAC inspection, DDoS, intrusion detection services, and security. Even ways that I access the storage is very, very important, so being able to mix and match. Also hybrid fabric with SDN. I'm not sure if you know some of these terms, but software-defined networks, network functions virtualization. Having an environment that is very native to that container or those virtual network functions and how they talk together and how they can migrate from system to system to system is definitely a challenge, but it has to be done in the new world. Low cost, dense, configurable, energy efficient, power. A lot of the key data centers are moving into areas where there's consumable power from dams and wind, but you're moving into maybe an old central office that doesn't have a lot of those opportunities. You're using typical power, and energy is rising. That's a key concern, so it's got to be energy efficient. And of course, it's got to be agnostic to the silicon vendor and the rack architecture. So those are some of the key things that, as a product manager, a strategic guy like myself, those are the things that when I look at new products and actually build products, these are the key things that I look about. And in the keynote earlier this week, this fell in my hands perfectly because I think there was a slide that Bill Carter, I believe, done. And we're moving from an Intel RSA, I'm not sure if you guys remember RSA, rack scale architecture, then to rack scale design, where really you're moving from a rack level physical aggregation point all the way into a deaggregated system in which everything is plug and playable. Again, I can put in compute sleds, GPU sleds, storage sleds, and it's all pooled within that environment with a common backplane infrastructure. So those were some of the key attributes that we looked at when we built this carrier grade platform, from a proprietary world to ATCA, which was a great thought idea. It was a great project that PicMig actually introduced. The problem with ATCA, though, is it just didn't have the oomph of future characteristics that things like OCP can have, the higher bandwidth functions, the higher backplane, but it actually set some of the standards on how do I manage an entire system? How do I build a system in which I have a commonality that any player can plug and play into? And those are some of the attributes, the foundation attributes that we use for OCP, OpenRack carrier grade. Within the open carrier grade system, again, the physicality of the system being hardened, having to support certain attributes of RFI protection, earthquake protection, low power attributes, use of power as I need it. Maybe I'll have an entire rack with one sled, but I'm going to grow that rack, so the power consumption has to be looked at. The depth, the size, because some of these environments, they can't withstand the Olympus sled. I mean, that Olympus sled is awesome, but man, it's so large, and rack and stack that thing takes up a lot of footprint. So really density and low power consumption and the size and shape. The workloads, looking at the future, maybe I just need one virtual machine, but that virtual machine may have to grow into millions of virtual machines. So how do I grow that attribute? How do I use open architectures to be able to grow and manage my SDN world for containers and my virtual network functions within the NFV portion? How do I manage these systems? I look at all the open source materials that are out there, from your typical IPMI. I'm not sure if you're familiar with IPMI. That's your board level functions. Then you have board management controller. And now you have this thing called OpenBMC that kind of replaces or enhances your IPMI. And then you have Redfish, which is another ONM attribute on how do I take that data to my top of rack switch and then to a management system. And then then the actual companies themselves have their own infrastructure to manage everything. So how does all this open architecture fit into that? And it's not cheap. It's not, it's not easy to do because there's so much out there. Networking and interconnection, again, you're going from a low level, maybe a 1 gig, 10 gig, 40 gig, all the way to 100 gig, and having the ability to aggregate those, that environment within the frame or the appliance is so important. And you're starting to see really cool things coming out, like MRIOV, multi-root hosting for PCI switching, where I can actually switch this CPU needs to go to this IO, and this CPU needs to talk to this CPU, or this CPU needs to talk to this GPU, so forth and so on. So there's some really cool things coming out that enable not just top of rack switching, but internal components of those appliances that just make life so much easier and controllable, lots of options. This was a slide that I showed a little bit earlier today, which provided a little bit of a foundation on our OCP carrier grade foundation. So Radisys did a really great job on allocating a specification for the size, shape, the seismic, the characteristics of a frame level system all the way up to 42U, and how all these sleds talk to one another through the top of rack switch. How do I manage it? How do I power it? How do I make things hot swappable? What are the key characteristics of these converged network providers? Can I offer a single, what I call a God box, that will enable all their compute and needs into one rack level environment? What ADLINK has done, and what we're now doing as well in the future, is building the sleds themselves and the components within those sleds and the architecture within those sleds. So again, we're a true believer in open architecture, number one. We're a true believer in actually ecosystem partners, in which we can take a Marvell and an NVIDIA and an Intel, Cavium, and the list goes on, a Qualcomm, and have the ability to plug and play those components, not just within that sled, but within that entire frame. So again, that's the true rationale of open architecture, is to provide as many options, valuable options, to our converged network friends to build out their network as they lead, not just for this year, but 10 years from now. This is kind of what the frame looks like. If you go to our booth, you'll see a half height, which is the small one on the corner here. Shipping these huge frames are, kind of challenging for summits. But it's really awesome, in which the front view is you have storage, full width storage sleds. You have half width compute or GPU or ARM-based sleds. Your PDU, your power management's all done at the bottom. And of course, your top of rack is at the top. And in this instance, you have 2 management top of racks and 1 ingress-outgress top of rack. And everything is pre-wired. So when this thing is delivered, it looks just like this, with everything pre-cabled. So you no longer have to do plug and play fiber cables or copper cables, which SFP do I want to use. And then the silver items is the DC bus bar. That's also an OCP characteristic, in which I can just slide in that sled. It connects into that power. And also the blind mate connectors for the fiber allow me to talk to the management and the top of rack switches. So great design. The cabinet itself is designed for certain seismic conditions, RFI conditions, and it's really built for hardened environments, but we also see uses in data centers as well. One of the key use cases I talked about earlier this morning is a real use case on deployment of server-based technology in a carrier-based office, in which you have a frame, you have your servers, you have all your cabling, and this could literally take up to 3 months from dock to power on, up and running. With the OCP carrier grade delivery, we've acknowledged less than 3 days, in which the entire system is delivered in a crate. You wheel it off, it's on casters. Take the casters off or keep the casters on, and you power it up, you connect it to the internet, and boom, it's up and running. However, so let me put the big what if in here. So what open architecture software do I want to put in here? Do I pre-configure it? Do I do it on an ongoing basis? What are some of those key things that, as a CTO or an IT manager, how do I want to manage it? Hardware, this is perfect. But how do I actually put all these open architectures on top of it? The cool thing about what we're also doing is not just us and our partners, but we do have some good foresight into what all these committees are doing. So we are members of ONF and CORD and ONAP and OpenBMC. We're part of the OCP. We're actually becoming a platinum sponsor of OCP. Us and our great partners with Nokia with their airframe system, Artisan, Cavium, Pentair. If you go to our booth, it's not just ADLINK pop there. We're a true believer of showing an Artisan box, showing a Radisys box, showing a Cavium box, and a Pentair chassis, using all of these different components. So again, it goes back to a simplified design, all in a fully integrated rack. Us as a manufacturer, we rely on multiple SIs, system integrators, to put this together and deliver to the customer. It provides serviceability, reliability that our customers need, because data centers also need some of this carrier-grade attributes, earthquake protection. Software is not the only element that can actually enable a system to go down and automatically transfer another system, but you want to make sure that doesn't happen through hardware. Redundancy, toolless, wire-free design, and significant operation savings. And just a shout out to all of our partners, really great guys here. Yes, some of them are directly in competition with us, but we do see this as being an open environment, really stressing all of these ecosystem partners. From an ADLINK perspective, now this is the ADLINK, okay, here we are, this is what we do. The actual OCP sled design came from an architecture that we had called Oxera. And Oxera will take that one sled that's OCP and enable that into multiple system types. So if I wanted an OCP frame level, that same asset can go into an OCP sled, or it can go into a 2U box, a 4U box with switching, different hardware components, or an orthogonal system that could be a 6U in design, using multiple reusable assets from the sleds themselves to NIC cards, to GPU servers, and then hardware-specific acceleration. So OCP is not just the only form factor that our sleds actually fit into. And really, you want to utilize any of these type of hardware assets for whether it's a security appliance that I want to distribute throughout my network, or a DPI appliance, something that's managing an NFV environment, but much smaller with switching and PCI switching, backbone, backhaul, all the way to edge and data centers. To finalize my presentation, I wanted to kind of show you guys a company that I was blown away with. Dynavisor's a partner of ours that optimizes storage and memory and compute capabilities. And we together went to one of their customers in Indianapolis, Indiana, and it's these two good old farm boys. I mean, these guys are awesome. They're just good old boys from Indiana, I guess came upon some money, and what they've done is they're actually going out and buying old shopping centers, these old malls. And within these malls, this one that we toured was called Eastgate Mall, built in the 50s. And of course, malls are struggling, so they shut down. And here at the bottom picture is what it looked like a few years ago. And if you look where the car is parked, we kind of walked around that, and they totally gutted it. And it's now a FedRAMP certified data center. And if you're not familiar with FedRAMP certification, there's 5 levels of FedRAMP. Level 5 is the bowels of NSA. That's about as high as FedRAMP goes. Level 4 is very high level, that you actually have inspectors, government inspectors, to come in once a week to ensure that you're meeting those FedRAMP pieces. And within this old shopping center, if you look to your left, the blue items are solar panels. That's the old parking lot. So the Sears and the JCPenney and all that stuff are distributed through it. And then all of the items inside this data center are surrounded by cages. So if you walk in, this would be Rolls-Royce, this would be Boeing, this would be National Institute of Healthcare. And they're looking at companies like ADLINK and Dynavisor and others with the OCP technology, because they can easily wheel it in, it's caged in, it's carrier grade, it's easy to install, it's low power. And these guys, even, I don't have a picture of it, where that car was parked, they build their own diesel engines and backup generators. What a great way to not just promote a very, how should I say, an environment within Indianapolis that's really hurting for jobs, hurting for the environment. And instead of tearing this place down, they've rebuilt it into a high-tech data center. And they have plans to do this all over the country. Fort Wayne, they just did another one. So very, very excited about this with our partners, Dynavisor. So to kind of walk away, just let you know, again, carrier grade OCP is really important. We have 3 to 4 different types of configurations. Of course, you can do it a million different ways. We have a half height frame, we have a full frame, we have different appliances that you can do. We're now coming out with a GPU dev kit specifically for the edge of mobile networks, all using reusable assets within OCP. And again, in conclusion, true believer in open standards and open architectures, how those can be used in these converged environments. Remember, I was talking about a converged operator from cable, IoT, to mobile, to telco line, how these architectures are now being standardized. Our collaboration in open architectures, not just within the OCP hardware committee, but those millions of other software open architectures that are coming down the pipe, and also being part of how do we build those together? How do we build these stacks in regards to an open architecture running on an open hardware architecture for management, throughput, containerism for Dockers on SDN, for virtual network functions? How do we make sure all this works and is secure and is doesn't cost zillions of dollars to actually implement? So ADLINK and our partners are part of all these different committees. And we are, again, ongoing dedication to the OCP carrier grade. The key thing about OCP is Facebook has done a great job on building that platform, just like ATCA did a good job building a COTS-based platform for the telecom. We want to ride that wave and really enjoy the benefits of OCP, but now do it for these converged network operators. Lots of good foundation there that we're building on top and hardening that's not part of that Facebook environment. And then extreme computing, making sure that I can meet the specifications in the future for throughput, looking at things like photonics backplanes, looking at 100 gig interfaces, different types of switching silicon, not just Broadcom and Marvell, but Red Rock Canyon and all these different architectures that we build into our programs to ensure flexibility and controllability within the system that's also reusable against different platforms. That's all I have. Well, thank you very much, and enjoy the rest of your day.